Hi guys, we're going to talk about how to decide what kind of triangle we have in this video here. I would recommend taking your scissors and just cutting the top and the bottom off on this side, just because we can probably use the extra edges but not the top and the bottom edge. Those won't come in handy. So you're going to fold on that dotted line, you're going to fold this one on that dotted line, and then you're going to cut along the solid line here and cut along the solid line there. So you should have this foldable right here. Okay? Alright. So this first thing we're going to talk about is it actually a triangle? Okay, so we're looking at this first little column here, or flappy window, whatever you want to call it, and this is a rule from earlier this year, and essentially we need to say that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Greater than the length of the third side. Okay? Greater than the length of the third side. So, if we're looking at this example here, we would say AB plus BC, so 20 plus 30, needs to be greater than 45. And we would check to see if that was true. So we would say 20 plus 30 is 50, 50 is greater than 45, so that works. Okay? But we have to try all of them. So then we would say AB plus AC, so we'd say 20 plus 45 has to be greater than that third side 30. And that is true, because that 65 is greater than 30. Now it has to work for all three sides, so we're going to try the third one, and that's going to be 30 plus 45. Is that greater than 20? Well, yeah, 75 is greater than 20, so it's true. So you have to try it 3 times. Okay, with all three sides alternating through. So you want to make sure that at the end of your statement you have the orange side for one of them, the blue side for another one, and the, let's say green side for the third one. Okay? So each side has to be on the end for all of them, and you add the other two. Okay? So we have to have, we're going to determine which set lengths can be sides of a triangle. So we're going to say greater than 3, greater than 6, and greater than 9. And we're going to check those 3. Okay? Probably shouldn't have written them so close together. Greater than 3, greater than 6, and greater than 9. We're going to check this. Okay? So I'm going to cover up the 3, and I'm going to say 6 plus 9. Is 6 plus 9 greater than 3? Yeah, 15 is greater than 3. So yes. Now I'm going to cover up the 6, and what's left over is 3 and 9. So I say 3 plus 9, is that greater than 6? Yeah, 12 is greater than 6. Then I'm going to cover up the 9, and I'm going to say 3 plus 6. Is 9 greater than 9? No. So this one cannot be a triangle. Does that make sense? Same thing. Greater than 4, greater than 5, greater than 8. So I'm going to start with the first one. 5 plus 8, is that greater than 4? Yes, because that's, what is that, 12, 13? Now take the 5. Is 4 plus 8 greater than 5? Yes. Now take the 8. Take out the 8. Is 4 plus 5 greater than 8? Yes. So this one can be a triangle. Okay. I'm going to leave the third one because we don't need to actually do all 3 of them. Okay, so you're checking. Remember, you take each of these and you see, if I add the other 2, are they bigger? If one of them is not, then you say no. If all of them are, then you say yes. Okay. For acute triangle, obtuse triangle, and right triangle, we're going to use the Pythagorean theorem. Okay? So, we're going to determine what kind of triangle we have. So, if it is, let's just start with the right triangle. It says if the square of the length of the longest side of the triangle is equal to the sum of the squares on the other two sides, then the triangle is a right triangle. Okay? So that's the rule. C squared equals A squared plus B squared. Okay? So if this theorem works, then you have a right triangle. Because remember, the Pythagorean theorem only works with right triangles. So let's go ahead and use that method here. Remember, the longest side is always the hypotenuse. The longest side is always C. The longest side is always C. So square root of 5 is going to be the biggest, so this is A, B, and C. So you say square root of 3 squared plus square root of 4 squared equals square root of 5 squared. And you're checking to see if that is true. Use that handy dandy TI-84 plus graphing calculator and type in second square root of 3 and then square it. That gets you 3 plus square root of 4, arrow out and square it. That gets you 4. Does that equal square root of 5 and then square it? Does that equal 5? Does 3 plus 4 equal 5? No. So this one is not a right triangle. Okay? Let's look at this other one. Does 5 squared, oh wait, so this is A, this is B, and this is C, because remember, C is always the longest side. So 5 squared plus 12 squared equals 13 squared, and we're going to check it. 5 squared is 25. 12 squared is 144. 13 squared is 169. Does 25 plus 144 equal 169? Yes. So since it's 169 equals 169, then yes, it is a right triangle. Okay? So if it's a right triangle, then they're equal. So if you look at this situation right here where it says it's not a right triangle, this is 3 plus 4, which is 7, right? 7 is greater than 5, okay? So if the square of the sum of the square of the length of the longest side is greater, if this side is greater than the other side, than the C, then we're going to have an acute triangle. Okay, so let's look at the acute triangle situation. Okay, it says, if the square of the length of the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is an acute triangle. In other words, if I have C squared is, greater than is not true. It's less than, I'm sorry. I was mixing up my ideas. So let me rephrase all of this again. Is less than the sum of the sides, okay? Then it's acute. So C squared is less than A squared plus B squared. So like we had over here, where it was 5 is less than 3 plus 4. That was from our one down at the bottom. And this was 7, right? 5 is less than 7. Then that means that the 5, since that was the C, then that meant that this was acute. Okay? So this is the rule. If the hypotenuse squared is less than the sum of the sides squared, then it's an acute triangle. So, same thing. What you're going to do is find the longest side. We're going to call that C. Okay? Longest side is C. Longest side is C. So A, B, C. So 7 squared plus 8 squared, and then equals 9 squared. We're just going to put an equals in there because that's just kind of a placeholder. Okay? And so we're going to check. 49 plus 64, and then equals 81. 49 plus 64 is 113. So, how does 113 compare to 81? Well, 81 is less than, okay? And remember, this side is the C side. So we're saying that C is less than the rest of it, so that means that this is an acute triangle. Okay? It's acute if C is less than, okay? So now let's talk about the other one. We've got 5.8, 3, and 7. Well, 7 is going to be C. A and B are the other two. So 5.8 squared plus 3 squared, and then maybe we'll say 7 squared. Let's just do that. Let's just make columns. Okay, so this is C. If we did that here, that might actually help us, right? Instead of putting the equal sign in, do that at the end. Maybe like that. Okay, so 5.8. So we're doing a whole bunch of testing, so it's good to not put the equal sign in there. Alright, so 5.8 squared is 33.64. 3 squared is 9. And 7 squared is 49. So this is 42.64. This is 49. So we're going to put our symbol in. Which one is bigger? The 49. 49 is my C squared, right? So that means that it's not less than. C is on the big side, right? The C is on the small side. So this means that this one is not acute. In fact, this situation is when we have an obtuse triangle, okay? Because C is actually greater than, okay? So for acute, it's kind of easy to remember because C is on the small side. And acute means small, okay? So obtuse, C is going to be on the big side. So if it's on the big side, then it's going to be obtuse, okay? So it says, if the square of the length of the longest side of the triangle is greater than the sum of the squares on the other two sides, then the triangle is an obtuse triangle. In other words, C squared is going to be on the big side of A squared plus B squared. It's on the big side. So obtuse means big, right? Alright, so let's do these two examples. So remember, it's A, B, and C. C is always on the largest number. So let's separate it. So say 6 squared plus 7 squared, and then 8 squared on this side. 6 squared is 36, 7 squared is 49, 8 squared is 64. 36 plus 49 is 85, and 64. So is C on the big side or the small side? It's on the small side. So this one is actually an acute triangle. So this one's not obtuse. If they told me to classify it, I would say it was acute, because C is on the small side in this problem. Let's do this again. 100 is the biggest number here, so that's C, and then we've got A and B. So we'll say 60 squared plus 50 squared. Draw a line and say 100 squared. 60 squared is 3600. 50 squared is 2500. And 100 squared is going to have 4 zeros. Okay? Now, 3600 plus 2500 is 6100. And this is still 10,000. So, is 6100, or is C on the big side or the small side? On the big side, right? So that means that this one is obtuse. Okay? Alright, thanks for watching. Have a wonderful day.